Okay, so the next thing that we're going to be working on is just adding a static load onto our beam. So piggybacking off the last example, we still have our acrylic beam all set up with the dynamic section property applied and the acrylic material property applied. So in this case, we're going to want to add a 0.1 pound force onto the top of our beam. So what we're going to do is once again just highlight that top grid point, go to assign, and then this time we're going to go to joint loads and then forces. So in this case, you can see that the Assign Joint Forces dialog box pops up, and we are going to change that force global X to 0.1 pounds. One quick note, I just always like to have replace existing loads underneath the options clicked off, just in case I'm going through and changing a lot of things and adding a lot of different forces. When you have it replace existing loads, SAP will automatically delete that initial force and then replace it with another one, rather than repeatedly adding forces on top of each other over and over again. So we'll hit apply, and you can see that SAP will give us a 0.1 arrow right where we applied our load. So the last thing we just want to double check before running our analysis is that we are analyzing in all 6 degrees of freedom. So in order to do so, we're going to go to Analyze, Set Analysis Options, and just make sure we have Space Frame checked off. So as you can see, it's going to check off all 6 different available degrees of freedom. So once we're done with that, just hit OK. And then we are ready to run our analysis. So what we want to do is press this play button right here to run the analysis. So in this case, you can see that we have both dead and modal cases. So we have a linear static and a modal, and they're both set to run right now. So since we're just using a static load, we're just going to go ahead and turn off that modal case. So we'll select it, select run, do not run, and then hit run now. So as you can see, right now I have one of the graphs displayed. In your case, you'll probably see a deflected shape. So in order to see the graph that I have, we're going to go to Display, Show Forces Stresses, and then Frames Cable Tendons. So in this case, I have the moment graph applied. So you can see that we have the highest moment down on the first node. So we have a moment of 1 going up to the top node with a moment of 0. So in order to see other different component forces that we have, you can go under the component part of the dialog box, click on all 6 different ones, and see the values that we're getting. So for this first shear one, you can see that we have a negative shear of 0.1, which makes sense because we had a 0.1 pound force applied in the positive x direction. So that shear on the bottom ranging up to the top once we got to that 0.1 would be a negative 0.1 just to keep everything in equilibrium. For the second shear, we shouldn't have anything applied, so that should just be 0. For the first moment, just like the same, we shouldn't have anything applied, but that moment 3, it should be the same moment that we saw before. So 1 on the bottom, 0 on the top. As you can see, this moment on the bottom is 1, which is what we talked about before, and as you guys know, the moment is going to be that point load on top times the length. So since we only had the 1 point load on top, 0.1 pounds, and then we had a length of 10 inches, our max moment on the bottom of the acrylic piece will be 1. So from there, if you want to see the actual displacement values of the different nodes that you have on your beam, you're going to go to Display, Show Tables, and then under the analysis results, we're going to make sure that we have joint output selected, and you can see that we'll be able to see the displacements, the reactions, and the joint masses. So from there, just hit OK, and we'll see these tables come up. You're going to navigate to joint displacements. So in this case, we had 5 different nodes because we had 4 different sections, with 1 being the top node and then 5 being the node that is the fixed end on the bottom. So as we can see, our maximum displacement is 0.83 inches, which completely makes sense. This would just be modeling, say, the force of your phone on the top of the acrylic piece. So we're going to have a relatively small displacement of 0.8 inches in comparison to the entire length of our beam. And just to make sure that everything makes sense, going down the nodes from 1 to 5, our displacement value should be decreasing until we hit 0. Definitely double check to make sure this bottom node is 0, because obviously we know that if we have a fixed end on the bottom of the acrylic piece, there will be no displacement.